Diffusion, the international science radio show.
We have a bouncer on the doors of perception.
The good, the bad, the ugly.
It gets pretty exciting.
The myths, the truths.
Toxicology.
Astroseismology.
Magnetism. The dark side.
Genetically engineered potatoes.
Planetoid.
Planetoid.
I love that word.
Hello and welcome to Diffusion. Sit back and relax while we regenerate your brain with weird and wonderful science. I'm Ian Woolf. On this edition, earworms and throat singing. But first up, here's news of rejuvenated, regenerated eyes. Visions of youth. Longevity researcher Professor David Sinclair at Harvard University has published a paper demonstrating the reversal of damage to the retina and optic nerve in mice with glaucoma, and reversal of aging damage to vision in elderly mice without glaucoma. Professor Sinclair used a similar technique to the one used to convert adult cells into embryonic stem cells. Instead of turning adult cells all the way back to embryonic cells with 4 Yamanaka factors, his team used a genetically engineered adenovirus to carry 3 Yamanaka factors into cells to turn their clocks back to youth. The rejuvenated cells then regenerate and heal the damage, restoring sight to the mice. They did get it to work with human cells in dishes, but not yet in living humans. If you use all 4 Yamanaka factors, then the cells in the body become cancerous. But if you only use these 3, then they rejuvenate and regenerate. If this story sounds familiar, it's because the same story came out in August 2019 when this research was published online as a preprint. And I reported on it then. It's taken 1.5 years for the paper to be published in Nature. Such is the speed of medicine that isn't a vaccine for a global pandemic. Professor Sinclair's team are the first in the world with a treatment that could reverse the loss of vision from glaucoma, rather than just pausing the progression of the illness. It's astonishing work, and I'm dying to see it replicated in humans. I was kind of hoping that Professor Sinclair's team would have published soon after the preprint, and that 2020 would see the work tried on humans. Not the only hope for 2020 that wasn't met. No other technique has been able to regenerate damaged retinal nerves. Logically, if you can regenerate retinal nerves, you may also be able to regenerate other types of injury and damage. If you can regenerate damage caused by aging in the eye, then you may be able to regenerate other age-damaged organs, perhaps even whole body rejuvenation and regeneration. Harvard University has licensed the technology to Boston company Life Biosciences, which, Sinclair says, is carrying out preclinical safety assessments with a view to developing it for use in people. David Sinclair is the Australian-born researcher who decades ago first found that resveratrol, found naturally in red wine and chocolate, could activate sirtuin proteins that promote longevity in yeast, and mice eventually. The headlines immediately went to how it would do the same in humans and spawned a whole industry of longevity supplements based on food extracts. Resveratrol supplementation doesn't seem to make you live longer, on its own. David Sinclair also discovered that another food extract supplement, nicotinamide mononucleotide, increased the levels of the energy and healing molecule nicotinamide adenine dinucleotide in cells, from the reduced level seen in aging back up to the higher levels enjoyed in youth. Professor Sinclair takes the nicotinamide riboside supplement with resveratrol himself and is doing research to prove that it improves health in humans, and he's set up a company to market the supplement once he's completed the research. If it increases longevity in humans, then it's very hard to prove without a very long-term and thus very expensive study. In mice, it changes their appearance from elderly to younger, but sadly it doesn't appear to do the same for humans. With this latest research, if it works in humans, David Sinclair will have a treatment that is easy to demonstrate and which could restore vision to millions of people and revolutionise medicine. Watch this space. The paper is titled Reprogramming to Recover Youthful Epigenetic Information and Restore Vision, and was published in the journal Nature. You're listening to Ian Woolf on Diffusion Science Radio. Send emails to science@diffusionradio.com. We're brought to you across Australia on the Community Radio Network and podcast over the internet on www.diffusionradio.com. Ever had a song stuck in your head? From 2010, here's Dr. Patrick Rubie explaining the science of earworms.
Ever had a tune in your head that you just can't get rid of? It gets a bit annoying after a while, doesn't it? In case you hadn't heard the term before, these tunes are called earworms, or stuck song syndrome, or involuntary musical imagery, or brainworms. Ugh. They're songs, tunes, or jingles that for some reason or another get stuck in your head. They are often simple and repetitive and start off as catchy. You'll remember a chorus or a bar or a riff, sometimes even a whole song. But eventually they can get quite frustrating and annoying. Earworm is a direct translation of the German word Ohrwurm. Believe it or not, earworms have attracted scientific curiosity for several years, with psychologists practically falling over themselves to formulate theories to explain them. Starting in 2001, Dr. Kalaris began a series of unpublished studies on what was termed cognitive itch. Kalaris thought that music had certain properties analogous to biologically active chemicals, such as histamine. Certain music would cause a cognitive itch, comparable to a physical itch that you can get with allergic reactions. You scratch this itch by repeating the music mentally. But, as with a physical itch, mentally scratching it only makes it worse, and you end up repeating the tune in your head over and over again. Okay, that's enough now, I think. Empirical studies have been carried out to try and better understand the science behind earworms. Some results indicate that earworms are experienced more frequently by musicians, who are of course exposed to music more frequently than the rest of us, and people with obsessive compulsive disorder, or OCD, who feel compelled to perform repetitive ritualistic behaviours which can end up making them feel quite anxious. So in order to understand earworms, perhaps a closer look at how we hear and remember sounds will give us a clue. Our memories are basically divided into two broad groups, which can overlap in some circumstances. They are procedural memories, the memories that you make when learning to drive a car, kick a football, or operate a microscope, and declarative memories, the memories you make when you try to recall a conversation, TV program, or a bunch of facts you had to memorize for an exam that probably kept you awake in bed sweating in abject terror the night before. Well, all memory involves converting an external sensory stimulus, something you see, feel, taste, smell, or hear, into a special chemical code stored in specialized neurons within our brains. Procedural memories are created and stored in the parts of our brain concerned with motor function, specifically the cerebellum. But declarative memories are a little more scattered and can be found in various parts of our brain. When a stimulus is first perceived by our eyes, ears, etc., The nerves in these structures relay it to the thalamus, a structure deep in the middle of our brain which acts as a kind of sorting centre. From here it can go to an area of higher processing, collectively known as the cerebral cortex, to make sense of what we have experienced. There are separate cortices being the plural of cortex, for sound, vision, touch, taste and smell. So where do memories come into it? Well, short-term memories are formed in an area of the brain called the hippocampus, which is part of a network of structures known as the limbic system. The limbic system sends information around the brain in a loop, which attaches emotional responses and behavioural responses to certain memories, such as the terror of a final exam and the pleasure of a delicious ice cream. If memories become long-term, they are stored in their respective cortices. Sounds in the auditory cortex, vision in the visual cortex and its association cortices, and so on. If you want to dig up a memory, you use another part of your brain, the prefrontal cortex, also known as the working memory, to retrieve it from the appropriate cortex of long-term storage. It's retrieved often along with the emotional and behavioural response you created with it. How well you can retrieve memories depends on how well they were stored to begin with, and how good the connections between the relevant parts of the brain are. Memories are impaired in amnesia and degenerative diseases such as Alzheimer's disease.
And now, the parts of the brain, performed by the brain.
Yes. Neocortex, frontal lobe,
Brainstem,
hippocampus, neural node, right hemisphere.
So how on earth does all of this relate to earworms? Well, sorry to disappoint, but the answer is we just don't know yet. There are several theories floating about, though. Earworms could be information that was overlearnt, and somehow the memory retrieval pathways are activated more readily than they should be. It could also be due to a temporary lapse in thought suppression, so that the memories intrude on our thoughts when they're not supposed to. What's becoming clear now is that it goes beyond normal auditory memory, and might involve more complicated long-term memory stores. We do, however, have some clues about what makes people more likely to experience an earworm. Two studies by C. Philip Beeman and Tim Williams, published recently in the British Journal of Psychology, have added some more pieces to the puzzle. One study asked 103 people recruited from railway stations and parks in England to recall and describe any catchy tunes that got stuck in their head. The other study recruited 25 people via an online advert to record their experience of earworms as they happened. And the results? 24% of earworms stopped people from performing other tasks, and 14% wasted people's time. How annoying. The researchers found no evidence that musicians or people with OCD were more likely to suffer from earworms than the rest of us. People who found music important or were more receptive to music were more likely to experience earworms, whether they were actual musicians or not. The experience of obsessive-compulsive disorder is different from earworms. People didn't generally report any anxiety or annoyance with the earworms, and the earworms usually disappeared after a day, unlike some of the behavioural traits of OCD. In the first study, when people had to recall them, earworms were reported to last several hours each time, but in the second study, where they reported them as they happened, they only lasted a few minutes. Popular tunes are more likely to become earworms. The first study reported a mixture of pop songs and children's TV tunes, with Pink Floyd mentioned 3 times, Guns N' Roses 4 times, and Justin Timberlake 5 times. But it doesn't seem like there is anything inherent in a sound that will turn it into an earworm. So what can you do about them? Psychologist Daniel Wagner has highlighted an interesting paradox in his theory of ironic processes. The more you try to consciously ignore something, the more you actually think about the thing you're trying to ignore. You have to remember it in order to force yourself to forget it, if you know what I mean. Beeman and Williams agree. When trying to distract yourself, an earworm could last up to 44 minutes, but if you do nothing, it lasts only 22 minutes. So it seems that attempts to distract yourself can make it worse. You should just do nothing. So what's the next step? Beeman says that brain scanning studies would be the way to go to see if earworms activated the same areas of the brain that are used when people voluntarily recall music. So there you go. The next time an irritating song gets into your head, just remember, you might have worms. I have to confess, I suffer from earworms a lot, especially when you half hear a song on the radio and you think, oh, that sounds pretty good, and then just that one segment of it sticks in your head for days afterwards, and it's agonising.
Well, what I don't like is when, of course, I've got the lyrics wrong, and I know I've got the lyrics wrong, and it's going through my head, and I don't know what I'm actually even listening to in my own head.
So you've practically made up a new song.
Which is sometimes better than the original.
Yeah. And the researchers looking at earworms now have actually reported that they've been around, they've been recognised for a long time. It was actually Mark Twain who reported one of the first earworms back in the 1800s. But they believe we might be more susceptible to them now because of the bombardment of information we get and the bombardment of sound and noise and stimuli we have with our modern communicative culture. So they believe that even though we don't consider it to be anything that's medically significant, it is of scientific interest, and it is something that we're recognising more and more, and people are out there doing studies to it.
I mean, I would suggest to people, if you really have a problem with this, since if you think about things, you can't stop thinking about them, and if you have trouble with the more passive Zen method, then set yourself other things to not think about. If you give yourself a big enough list of things to not think about, you'll be so busy thinking about not thinking about them that you'll forget the original thing that you didn't want to think about. You overwhelm the mechanism.
Yes, I think they had a look at one of the things in their study. They found that by listening to other music or by putting in another song or something, that's what most people use to try and forget about their particular earworm. And whether it worked or not, we don't know.
That was Patrick Rubie and Ian Woolf discussing earworms and their love of Justin Timberlake.
Thank you, Patrick. Still on the subject of music, from 2005, the other week, listening to Joe Wolf and Jermin Cheng talk about the harmonic singing used by Tuvan throat singers, wouldn't you like to know how to make those amazing sounds yourself? Here's Noel Hanna with a lesson in Tuvan throat singing.
Do not adjust your set. The sound you are hearing is what is known as throat or harmonic singing. While it may not sound like the top 40 music you're used to, harmonic singing is a popular form of music in many parts of the world, most notably Tuva. Tuva? Never heard of it? Well, this small country in the Russian Federation is home to a nomadic people thought to have invented forms of harmonic singing in an effort to replicate sounds from nature. Since then, throat singing, or kume as it is known locally, has become something of a national pastime, with regular international throat singing festivals held. In order to explain the basics, I'll first need to tell you how we as humans make sounds. Basically, there are two types of sounds we can make. By passing air through a gap in the lips, we can whisper or whistle. Speaking and singing make use of the vocal folds or vocal cords, as you might have heard them called. These are folds of flesh in the throat that can be made to vibrate at different frequencies by tightening the muscles around them. In speech or singing, we produce many frequencies of differing amplitudes in the range 0.2 to 8 kHz. So how does this apply to throat singing? Well, the vibration produced by the vocal cords sends pulses of air into the mouth where they can be modified to alter the sound before it comes out. It is possible to emphasize one of the higher frequencies so that it is heard above the others. By changing the shape of the mouth, different notes can be chosen. If you listen to the next example, you can hear a low drone accompanied by a very high-pitched sound. Now I have you interested, you're going to want to know how to make some of these sounds yourself. Luckily, it's not too hard to get started. Open your mouth and sing a note as you would normally. Then, bring your tongue up to the roof of your mouth, forming a cavity at the back. When you sing again, you will hear that the note has been modified. By experimenting with the position of your tongue and the shape of your lips, you should be able to isolate some high-frequency sounds. As I mentioned before, harmonic singing is popular in many parts of the world. In countries such as Mongolia, China, Uzbekistan and Kazakhstan, similar styles of throat singing can be heard to Tuva, whereas Canada, South Africa and Italy have developed very different styles. Interestingly, studies of Tibetan monks who use harmonic singing as part of their meditation have shown that their brainwaves are in sync with the frequencies that they are singing. It looks like there might be more to it than you think, so you better get practicing.
And that was Noel Hanna instructing us in Tuvan throat singing. You can see the videos of my 2020 Zoom interviews on the Diffusion YouTube channel. Subscribe and like at youtube.com/c/diffusionradio. And that's all from us this week on Diffusion. A big thank you to my 4 monthly donors on Patreon: Stormy, Yevgeny, Joanna and Ian. Are you a scientist, artist, biohacker or maker who'd like to be interviewed about your work? Would your company like to sponsor Diffusion? Send your contributions, opinions, helpful suggestions and donations to science@diffusionradio.com. That's science@diffusionradio.com. Please like the Diffusion Science Radio page on Facebook and rate the show on iTunes. Tell your friends. Follow me on Twitter @IanWoolf. The news music was Rhinos Theme by Kevin MacLeod of Incompetech.com. I produce Diffusion, which is broadcast around Australia to 28 stations on the Community Radio Network, including Radio Blue Mountains 89.1 FM in New South Wales, 8CCC in Alice Springs and Tennant Creek, 2 MVR in Nambucca Valley, 3 MBR in the Mallee Border districts of Victoria and South Australia, City Park Radio 7 LTN in Launceston, Tasmania, and 2XXFM in Canberra. Diffusion is narrowcast on Indigo FM 88 in northeast Victoria. Diffusion is syndicated globally on the National Science Foundation's science360.gov internet radio station and also on astronomy.fm. Subscribe to the podcast on the Diffusion website, www.diffusionradio.com. That's www.diffusionradio.com, and check the website for links, photos and videos about this week's show. If you enjoyed the show, you can explore more than 1,000 previous episodes archived on diffusionradio.com, where the shows are labelled by keywords, so you can focus in on the stories you want to hear. Join my patrons at patreon.com/diffusionradio. Make a donation. Join my patrons at patreon.com/diffusionradio. Make a donation through paypal.me/Ian Woolf. Support Diffusion by buying from the affiliate links at diffusionradio.com/support. I'm Ian Woolf. Join us inside your audio device of choice for more science wondering next week on Diffusion Science Radio.
Science is fun. It helps you to learn, to know, and to appreciate. When you study science, you may go on field trips. You discover the marvelous interrelationships between all living things. You learn to read the history of the Earth as it is written in rocks and fossils. You find out what makes things tick, everything from a molecule to a living organism. In the study of science is found the most useful and satisfying knowledge of man. Knowledge of his physical world, its past, its present, and its future. And in your moments of relaxation, now and in the years to come, you will find the study of science leading you into fascinating pursuits. Photography, collecting. Why study science? Study science because you will find in the study of science a richer, more rewarding life.